Hello dear students, welcome to the channel and very welcome to this playlist in which we are discussing about 8051 microcontroller in detail. And if you are on this video, that means up till now we have discussed about all the theory that microcontroller 8051 uh, offers in the basic course. And from today onwards we are going to discuss about the programs of 8051. So if you are directly jumping to the programs and you are unfamiliar with theory, I reckon you should check out the playlist in which we have discussed about everything in detail, from the memory organization to the instruction sets, from addressing modes to the programming of ports, input output ports, and from block diagram to pin diagram. Everything has been covered. We have also covered the timers and counters. We have also covered the interrupts. Everything has been covered, so you can check out it in the playlist above. The link will be flashing on the top right hand side corner of your screen in the I button, so you can click on it and go there. And it would be more easier if you have checked out the playlist, because I might use some references from it. But even though you don't know, no need to worry. You still will able to learn that. So without further ado, let's get started. First program that we are going to discuss today will be the program which we use to store the 8-bit data in the register. And the question or the program statement is to write the program to load 5H into the accumulator and then transfer the same data in to DPH and DPL and B registers. Okay, repeating one more time, that we have to write a program to load data 05H into the accumulator and then transfer the same data to DPH and DPL and then B register. So here's the simple explanation which has been given, so we can understand what exactly we are going to do, because this is our first program that we will be seeing. We will may require the explanation. So first, what do we have to do? We first have to use the immediate addressing mode to immediate data 05H, and then load this data into the accumulator. We will use move A, right? So first, what instruction we might have to use, that should be clear, and without that it would be almost impossible to do the programming in not only 8051 but in any controller. So first you have to move the data 05H into the accumulators. For that, what instruction is more suitable? So move A comma 05H, this instruction with immediate addressing mode is perfect for such kind of operation, so we are going to use that. Now that we have to transfer the data to DPH register, so how do we do it? What instruction we are going to use? So we will be using MOV, or move instructions in general we call it, MOV DPH comma A. What this instruction will do for us? So it will move the content which has been stored in the accumulator to the DPH. Okay, because always remember the how do we get the data into something? We use move instruction, and what will be the uh, what will be the correct order to mention them? So the one who is sending the data stays on the right side, and the one who is receiving the data stays on the left side. Okay, same way, now you want to transfer the data to DPL register from accumulator. Again, what will you do? You will use again move command. This time, instead of DPH, we will be using DPL. Okay, so we'll use move DPL comma A, which will simply move the instruction 05H from accumulator to DPL. And now we want to transfer the data of accumulator into register B also. So now to transfer the data of accumulator to register B, we will again use the instruction move, as we are performing the same expression or same instruction is getting executed. Now tell me, if I want to make an algorithm based on this instruction, what would be the algorithm? What would be the steps of this algorithm? So the first step would be load the accumulator with the immediate data 05H, would be the first step of my algorithm. In the second step, I will copy the content of accumulator to register DPH. In third step, I will copy the content of accumulator to the register DPL. And in the fourth and the final step, I will copy the content of accumulator to register B. And then it would be all done. Now if you want me to make a flow chart of it, how will I make the flow chart? So always remember, in the flow chart we always have to start and end the whole chart, and for that we always use the oval shape. Okay, so we use the oval shape, you mentioned start in it, then these arrows which will basically give you the flow of your diagram, and whenever you do the process you have to mention that in the rectangular box. So we are performing the process, load the data 05H in the accumulator, so we mentioned that in the rectangular box. We loaded the data 05H in the accumulator, then we store the content in the register DPH. So again same flow, and again the rectangular box, and we will mention the second step, store the content in register DPH. Then again as we are not changing our process, we will use same arrow and same rectangle, and we will mention the third step to store the content in the register DPL. And then finally the fourth step, to store the content in register B, similar way. And then we will again use the oval shape, and then we will end, or we will write end or stop here. If you want to see the instruction and the performance, which will be instruction and the operations performed by that particular instruction, that would be visible here. See towards the bottom of the screen, move a comma hashtag 05H would initialize accumulator, and it will enter 05H in the accumulator. Then move DPH comma A will transfer the content of accumulator to DPH register. Similarly, the content of DPL and content of accumulator will be transferred into DPL and B as well with the same instruction. I think that is enough explanation for this program. Let's move to the second one. Okay, so there is no mention of program statement here, so let me read out the program statement from outside. So the program will be written to store the 8-bit data in the register this time, and a program statement will look like this. Write a program to load the data 05H into the accumulator, and then transfer the same data to the register R0 of register bank 1 and register R1 of the register bank 1. Okay, so again we have to store the data 05H in the accumulator, and then this time where are we pasting this? So we are pasting in the register R0 and R1 of register bank 1. Remember, we studied the memory organization and the registers of 8085 or 8051. So we are going to use the understanding of that, plus whatever addressing modes and instruction sets that we have learned, we are going to use that. So again one more time, we will be using the immediate addressing mode to load 05H into the accumulator, And what instruction we will be using? Again, we will be using the same instruction that we used earlier. Move a comma 05h, because the purpose or motivation is the same. Now we want to transfer the data to register R1 of selected register bank R1 or register bank 1. So what instruction we will be using? So we will be using move R0 comma A. Okay, and to transfer the data to register R1 of selected register bank 1, what instruction we will be using? We will be using move R1 comma A. Okay, so move R0 comma A and move R1 comma A. Again, what will be the algorithm and what algorithm will look like here? So first we will load the accumulator with immediate data 05h. In the next step, we will copy the content of accumulator to the register R0 of selected register bank. In the third step, we will copy the content of accumulator to register R1 of the selected register bank. That is so simple, right? And the flowchart of the same will be visible on the right hand side, as you can see. Again, we will mention start in the oval shape, and then we will see the first instruction in the rectangular box with the flow arrow. So the first instruction would be to load the data in the accumulator. So that first step will be mentioned in the first rectangle. The second step will be in the second rectangle. But this time, remember how many register banks did we had in 8051? We have 4 register bank 0, bank 1, bank 2, bank 3. So this time you have to select the bank. You have to select in which bank you have to send your data, right? Because if you remember, if you don't select the register bank, what will happen? It will by default select the register bank 0 and the data will be shifted to register R0 of register bank 0. So it is important to select the register bank 1. And how do we select the register bank 1? Okay, I will tell you that when we discuss the instructions and the methods which we use for that. But for now, remember that you have to select the register bank. The third step will be to move the data from accumulator to register R0 of bank 1, in which we have used the instruction. We use the move instruction for that. And in the fourth step, we will be using again move instruction to move the data from accumulator to register R1 of the bank 1. And once that is done, we are going to stop and we are going to use the oval for stopping or ending the algorithm or flowchart. Now that we have learned the flowchart, let's discuss about the implementation with the use of the instructions. So this is something that can be done using two different methods. First, in first method, what will we do? The first step of the both of the methods will remain same. We will be moving 5h to accumulator with the use of immediate addressing mode move instruction. Move a comma hashtag 05h, right? So we are sending 05h to accumulator. Now we have to select the register bank 1. And how do you do that? So if you remember, when we have discussed about the memory organization of 8051, we have discussed about selection of different register bank. In that, if you want to select the register bank 1, you have to use set b and clear, two instructions. So first we will be using set b psw.3. It will set the third bit of psw, and we will clear the psw.4, which will clear the fourth bit of the psw to select my first bank. Okay, and then we will move or transfer my 05H to bank register R0 and register R1. So for that we will be using move 08H comma A which will transfer the content of accumulator to register R0 of the selected register bank, and to send it to register R1 you have to write move 09H comma A which will transfer the content of A to register R1 of selected register. Now if you have the question that why did we mention 08 and H and 09H, then I recommend you to check out the video in which we have discussed about the memory organization and discussed about the registers and register banks, all four register banks of 8051 in detail. So that video will answer your question 05H and Y08H and 09H. I'm not explaining everything here because it will drag the video too long and it will almost kill the purpose of having the whole playlist. Now let's see the second method, in which we have already discussed or we have already selected register bank 1. So we will simply use move A comma hashtag 05H. So it will assign the 05H into the accumulator. Then we will use move 08H comma A which will transfer the content of accumulator to register R0 of the selected register bank. And in the same way we will use move 09H comma A which will transfer the content of A accumulator to register R1 of selected bank. So that was our second program, pretty simple. Now let's move to the third one. So this is the third program, and what would be the problem statement of the third program? So we are using this program to add two 16-bit numbers. The program statement is write a program to add two 16-bit numbers. Let the number be 7856H and 1234H. Okay, so numbers are 7856H and 1234H. We have to store the result of the addition in data pointer register, DPTR, data pointer. Okay, and either way this is a 16-bit addition, so we have to store it in data pointer either ways. So let me explain the program statement or elaborate the program statement in different stages in order to understand how we are going to do it exactly. So first we have two 16-bit numbers 1234H and 7856H. We need to add the two LSBs and the two MSBs separately in 8051 because it is an 8-bit microcontroller. And we will store the first number in the data pointer and the second number in A and B register with the accumulator consisting least significant byte or LSB, and register B will be considering will be having MSB of the number. Then we will add two LSBs, means the number in register DPL and the number in register A, and then we will store the result of LSB addition in DPL only. Then we will add other two MSBs, and the number in the register DPH and number B in the register B will be added together, and we will store the result of that addition in DPH. Now let's see the algorithm, how we are going to how exactly are we going to do it. So in the first step we will start. In second step we will get the first 16-bit number in data pointer. Third step we will get LSB of the second number in register A. LSB means least significant bytes, or the last two numbers, in this case last two numbers, because this is a 4-digit number, so last two numbers will be saved in the accumulator, and first two will be in register B, which are MSB. So that is our fourth step as well. Get the MSB of the second number in register B. Then the fifth step is to add the LSB of two numbers, least significant bytes of two numbers. So the LSB is stored in the register A and DPL, so that will be added together, and then we have to store the result of this LSB addition in DPL only. Next step would be load the MSB of the first number in accumulator and add the MSB of two numbers. Okay, so this time we will have DPH and register B, addition of the content of DPH and register B, and we have to store the result of MSB addition in the register DPH, and then we will stop. Now the flowchart of that is also given here. I'm not going to take so much time this time. I'm simply going to tell you. First we will start it in the novel, then we will load the number 1 in the data pointer. First number in the data pointer, not number 1, the first number in the data pointer. We will load the second number in accumulator and register B, with accumulator consisting least significant byte and register B consisting most significant byte of that number. Then we will add two lower bytes. We will store the result of this addition of the two lower bytes in the register DPL. Then we will add two upper bytes and we will store the result of this addition of two upper bytes in the register DPH, and eventually then we will stop. So this addition of two lower bytes, I'm repeating one more time. For that, where do we get two lower bytes? So first one will come from DPL, second one will come from register A or accumulator, and in case of the MSBs, the first one will come from DPH and second one will come from register B. Now let's quickly see the program to understand the instructions here. We will first move the 1234H into the data pointer. So we are going to use simply move instruction for that and immediate addressing mode for that. So move dptr comma 1234H to load the first number in the data pointer. Then see what is the second number we have. Okay, in question I have told you the second number which we wanted to add with 1234 was 7856H. So least significant byte of 7856, which means the last two digits 56. So you have to move this 56 into the accumulator or register A. So you will what will you mention? You will mention again move command with the immediate addressing mode, move A comma hashtag 56H to load the LSB of the second number in the register A. Again, what was the number? 7856H. So what would be the most significant bit or MSB or the first two digit of the number? So it would be 78. So this 78 is going to be stored in the register B, and for that again we are going to use a move instruction with immediate addressing mode. So move B hashtag 78H to load the MSB of the second number in the register B. Now what do we have to do? See the algorithm or the flowchart. We have to add the lower two bytes. Okay, lower two bytes. Now if you remember, when we have discussed about the data pointer in detail, the first because the data pointer is a 16 bit register, so the first two digits or the MSB will be stored in where? Because we have divided DPTR or data pointer in two different sections, which were DPH and DPL. So this 12 will be stored in the DPH and this 34 will be stored in the DPL. Now we have to add lower two bytes. Now among 1, 2 and 3, 4, which are lower 2 bytes. So 3 4 will be lower 2 bytes, right? Because you see ones number, tenth number, hundredth number, and thousand number. So these two will be lower 2 bytes based on that. So you have to add 3 4h with what was the lower 2 bytes of the 7 and 5 6h. So it was 5 6. You have to add 5 6 with 5 6h with 3 4h. For that you will what are you doing exactly? So 3 4 was the content of DPL, 5 6 is the content of move A. Now you have to add both of them. So we will be executing instruction add A comma DPL, which will add two LSBs. Now you have to store the result of this addition into DPL. And if you remember correctly, whenever we perform any arithmetic operation, the result will always be stored where? In the accumulator. So now the result is already stored in the accumulator and you have to move it from accumulator to data pointer. So for that, what instruction we are going to use? So again we are going to use the move instruction. So we are going to use mov DPL comma A because we want to move it from accumulator to DPL. So you will use move DPL comma A, which will store the result of LSB addition in DPL register. Now what are you going to do? Because uh, every as I've said earlier, every arithmetic operation will take place in accumulator only. So you cannot simply add the uh, two MSBs directly, because one MSB is in the DPH register, second MSB is in the register B. So there is no accumulator. So you have to send the data from register B to accumulator, or you can also send the data from DPH to accumulator. Either of them is fine. So here we have sent the data from register B to accumulator, and for that again we are using the instruction move A comma B, which will load the MSB of the second number, which was exactly 7 8 earlier, to the accumulator. And now that we have it in the accumulator, we are going to add the add both of the MSBs. But remember one thing, earlier we have already added two numbers, so we have the carry. Because what will be the sum of 56 and 70? What will be the sum of A comma DPL? We don't know. We might have a carry. So for that we have to use ADDC. Okay, add C, because we had the carry. So this time only simple add instruction will not do. We have to use add C. So we are using add C A comma DPH, which will add two MSBs. The one which is stored in the DPH. What was the stored in the DPH? Remember, 1 2H, and the one which is stored in the A or A register or in accumulator, which was previously in register B. So which was previously in register B? What was previously in register B? 78H. So we are adding 78H with 12H. Now that the addition is done, again you have to move this result from accumulator to DPH. So just like we did it in after the addition of two LSBs, we are going to do the same thing after the addition of two MSBs. We are going to use move instruction to move the result of the addition from accumulator to DPH. So this instruction move DPH comma A will store the result of MHB addition in DPH register, and the result of this addition which you are going to see will be 8A8 8A8H, which will be visible on your screen, or you can check out on the bottom of the screen as well. Now let's see the next program statement that we have, and that's going to be quick because we are running out of time here. So this program is used the for the discovery of the ones complement of whatever number there is. The program statement says write a program to find the ones complement of a number. Assume that the number is stored in the register R3 of the register bank 0. So two things, we have to find the ones complement of a number. Second, we have to assume the number is stored in the register R3 of register bank 0. But the second statement only tells us two things. First one, it is stored in the register R3 of register bank 0. Second thing, remember register 3 is a 8-bit register, so number will be of 8-bit, will be 8-bit number. Okay, so let me explain the whole thing one by one about how we are going to do it. So ones complement a number of a number, first you have to know what is a ones complement. So it means to invert each bit of a number, right? So if you have 0, you have to because we are going to use the binary system only, because because first we what do? We use hexadecimal in the microcontrollers, but to find the ones complement, first you have to convert it into binary and then find the ones complement if you want to do it manually. But luckily microcontroller has a inbuilt command for it that we can use. But uh, if you ask me, if you want to find it ones complement of a hexadecimal number, you first have to convert it into the binary number, and then you have to invert zeros, you have to invert your number, which means if you have 0, so replace 0 with 1 and replace 1 with 0, and you will get the ones complement. So that we have to find, and then after finding it, you again have to convert it into the hexadecimal. But because we have the direct command for it, we don't have to do all the thing, but in manual case you have to do it. So just getting familiar with ones complement. So here what are we going to do? First we will load the number whose ones complement is to be found in the accumulator. Okay, because every arithmetic instruction or every arithmetic operation takes place in the accumulator only. Then we are going to use the CPL instruction, which is used to compute ones complement of a number. We will find the complement in the accumulator only, and then we will store the result back in the register R3 of register bank 0. Okay, so what would be our algorithm? So step 1 will be selecting register bank 0. First we have to select the register bank. Second, we have to store the number in the accumulator. Third, we have to find the complement of the number, and fourth, we will have to store that result. But store the result where? Store the result in the R3 register. Okay, so what would be the first method if you ask me? First you will select the register bank. For selection of register bank 0, we have to use the clear twice. We have to use clear PSW3, you have to use clear PSW4. Before going there, just see the flow chart. Simple. First we will select the register bank 0, then we will load the content of register R3 in the accumulator, because every arithmetic operation takes place in the accumulator only. We will then take the complement of the content which is stored in the R3, and then after taking the complement, we will again store the content which is currently stored in the accumulator to R3 register back. So first we have selected the register bank 0 with the clear PSW.3 and clear PSW.4. This is I'm talking about instructions, by the way. Then we have used the move command to move the data, or to move the number from register R3 to accumulator. So we used move a comma r3 to move the number from r3 to accumulator. Then we used cpl a to find the ones complement of that number, and with the help of cpl a you can find the ones complement of whatever number you wish to. So once we have the complement ones complement of a number, what we are going to do again, we are going to send the name number to r3 register back. So for that again we are going to use the move instruction. We are going to use move a comma r3 to store the result in the r3 again, and that would be it. And the second method would tell us that we can directly select the register bank 0 initially, or if you don't want to select, you simply reset your controller, or you if you have just started your controller, by default we are going to use the register bank 0. Remember, when we have discussed about register banks in detail, I have mentioned that if you don't select any register, if you don't select any register bank, the register bank 0 will be selected by default by the microcontroller. So here, even if you don't select the bank and then implement the last three instruction, it will give you the same output. Okay, so that you can do as well. Now let's quickly move to the next program. So next program and the final program is to find the two's complement of a particular number. Okay, let me read you the program statement. So program statement says, write a program to find the two's complement of a number. Assume that the number is stored in the register R3 of the register bank 0. Right, pretty much same as what we did in the previous program, but this time you have to find the two's complement instead of one's complement. Now firstly, what is exactly two's complement? So think of it as the same thing which we did earlier, which means just find the ones complement of a number, following the same procedure which I have mentioned earlier, and then add 1 to it. Okay, just find ones complement by simply converting hexadecimal to binary, and first convert hexadecimal to binary, then invert the number, replace 0 with 1, 1 with 0, and whatever result you get, add 1 in it, and after adding 1 in it, again convert it into the hexadecimal form, and the number which you will be getting will be the two's complement of your number. So that way you convert your number to two's complement of a number. So if you are smart enough, you already know what we are going to do here. Okay, so if you are thinking about mentioning a special program to find two's complement, or a special instruction particularly to find the two's complement, there is no special instruction to find the two's complement in 8051 microcontroller. But remember, I told you how we find two's complement. You first find one's complement and then add 1 to it. So can't we do one thing? Write the same program, follow the same steps which we have followed in the previous program, but after finding one's complement, we store which is stored in the accumulator, we add 1 to it. Right, that can be done. So I'm not explaining algorithm in a flowchart this time. I'm directly coming to the program itself, because that way it would be more easy to understand and it would be more relatable this time. So see, this time again we are using the CLR PSW.3 and CLR PSW.4 to select the register bank 0. something that we did in the previous program as well. Again we are using move a comma r3 to load the number from register r3 to accumulator, as we are going to use the cpl command in accumulator only. So we are using cpl command cpl a to compute the ones complement of a number. Now this ones complement will be stored in the accumulator only. Now we have to find the twos complement. What is two's complement? So you first find ones complement and add 1 to it. So can't we use simple add instruction with simple with immediate addressing mode, with the application of immediate addressing mode? So we are going to use the add a comma hashtag 01 h. So see, here we have used the immediate addressing mode. We have added 1 to whatever content present in the accumulator. And what is the content present in the accumulator? The ones complement which we have just found. So this sum will give you the twos complement. So you just added one instruction and found the twos complement out of it. And in the final instruction, you will simply moving the content of the A register or accumulator into the R3 register, right? Which will be equivalent to storing the result in the R3 register of R0 bank directly, right? So that way it would be more simple. And remember, as I've already mentioned earlier, that if you even if you skip the first two instruction, it wouldn't matter at all. It will be all the same, because by default the microcontroller will select the register bank 0 unless and until you have already selected some other register bank and you haven't cleared it after completing your program. Okay, so that would be uh, easy, and you can remove first two lines or first two instructions from the program if you have a habit of clearing your programs after execution. So that would be it. This was your fifth and final program that we learned today. If you have any questions or queries related to these programs, mention that in the comment section below. I will try to answer them as soon as possible. And if you want me to make more videos related to the microcontroller programming, mention that as well. It would be more beneficial for you and me as well to learn more about microcontroller programming. And any feedback related to the channel, please mention that in the comment section as well. If you have uh, any recommendations or video requests that you want me to make on a particular topic, mention that in the comment as well. So I will be seeing you next time with the next video in this playlist. Until then, thank you very much for listening. Keep happy, stay safe, and goodbye for now.